There we go. I just need to mute the recording because I'll get some feedback here. All right. So one of the pieces of coordination that needs to happen very early in the project is how to connect the models between each other using the same insertion point and connect the project to a topography. And that process is usually misunderstood or it's poorly documented. And I'm going to start discussing what is the coordinate system in Revit, and then how can we identify a common anchor point that will align the different scopes, the different disciplines in the same exact geographical location. And so this is a representation of the navigation box that you see in the 3D view. If you see the 3D view, you've probably seen this box. And the coordinate system in Revit is very, very different from the one you see in AutoCAD or in other programs. Most CAD-based programs have a unique coordinate system, or WCS, the work coordinate system, and it's an absolute 0, 0. And a Cartesian system that that serves as a reference for every geometry that you create. You create a dot, a point, a plane, or a volume. It's all reporting coordinates relative to that 0, 0, 0. But in Revit, we have 3 different points that are important to understand. To get started, one of the major difference between CAD and Revit is that CAD it's almost limitless. It's almost unlimited in the size of a project you can have. You can create in AutoCAD a very, very small project and a very, very large project. In Revit, you cannot do that. The maximum size of a project is 20 miles. And think of this 20-mile cube or a 20-mile sphere, where all the geometrical information needs to be contained in this sphere. And this has to do with the distance at which the analytical numerical results are going to start failing. So when they invented Revit, they estimated that if you go beyond 20 miles, then the refresh rate of the views and the analytical results of the models we're going to start displaying unreasonable mistakes. And so that's why they cap the size to something that's about 20 miles. And so inside this cube, there are 2 orientations, and I think you're familiar with the Project North and the True North. The Project North is the orientation that align the project perpendicular to our sheets. And the True North, it anchors the project to the orientation of a project to the geodesical orientation. When we start a project using the out-of-the-box template, both the True North and the Project North are exactly in the same spot. They're aligned. But when we start associating the project to a location, and then and we specify the angle declination between project north and true north. Then you're going to see in the navigation box that these box actually tilt, right? So the true south is not the same as the project south, or the true north is not the same as the project north. The importance of having a true north orientation is that you can get very precise, accurate solar analysis. And then the advantage of having a reasonable project north is that the readability of the project relative to the sheet orientation. And so inside this angle, the angle between true north and project north, is something that you can define inside a project. I'm going to show you how to do that. This information is something you will get from the civil drawing or from any record document of the existing site. It's important to use as much decimals you can, because an error in orientation of a decimal, particularly in a very large size, can translate in important dimensional distance, in particular when the point is far, far away from the project. Okay, so inside this big modeling space, and unlike the AutoCAD space, in Revit we have a limitation of size, like I say. When we bring a DWG, when we link a file into another one, and that file has geometry far away from the 20-mile limit, you're going to receive this message that the extent of the geometry is greater than 20 miles, and that it will reduce reliability on the graphic behavior. And so if you see this message popping up on your project when you link a survey, then we need to go back to the survey and do something. We need to clean the survey. Sometimes the geometry has an extent greater than 20 miles because there are floating invisible objects in the periphery, or there are unrecognizable geometry that Revit is unable to translate coming from Civil 3D or from other CAD software. So we need to go back into the AutoCAD file and make sure that the extent of the file is less than 20 miles. Now, when it says undesirable graphic behavior, it's very unpredictable. Like if you ignore this message, and for example, you render, and then you see that the render has areas that are not visible, or if you switch to an exterior elevation and it appears cropped from nowhere, or you're in a floor plan and the text in the CAD file appears really, really, really distorted, that is a symptom that the file is greater than 20 miles and Revit cannot process it. And so it's important to go back to the CAD file and change it. All right, so inside Revit, we have 3 points that we need to understand. And pay attention, because this is in the test on Thursday. The internal origin is the center of this 20-mile space. It's also called the startup point. And this point is visible. You can actually turn it on as a subcategory under the site category. And it's displayed as a gizmo, X, Y, and Z gizmo, similar to the one you see here. It's a gizmo that you see as the center of the space. But this point, it's relevant only if you are exporting the file. Like when you export a file, you can export it relative to a shared coordinate or the origin, or you can link a file using the internal origin. So when you link two Revit files, you have the option of choosing the method, the anchor point. Those options are internal origin, shared coordinate, or manual. When you link two files using the origin, then it's the center of it, the center of the 20-mile space with the center of the 20-mile space in the same spot. The next point is called the survey point, and another point is called the base point. So again, the relevance of the internal origin is that you can export things using this point, or you can link files using this point. But that's it. There's not other use of this point. This point doesn't report coordinates. You cannot read any dimensions out of that, any values in the origin. It's just there. The point that defines the shared coordinate system, it has this shape. It's a little triangle with two arrows. The x direction is represented in red, and the blue is the y direction, and z is the green direction. And so the survey point indicates a spot in the project that is associated with a geodesical survey point, ideally. Unlike the AutoCAD file, the survey point is a relative point. You can select it, move it, and place it anywhere in the 20-mile space, and still going to be 0, 0. The survey point 0, 0 is 0, 0, but it's a relative point. You can relocate it if needed. And so one of the first exercises when doing BIM execution projects is to make sure that the team agree what the survey point is. So that's usually the intersection of two streets, or the corner of a boundary, or the corner of an existing building, or associated with a geodesical point that is usually available in a survey plan. So that conversation needs to happen as a team. If you have a survey, get the surveyor, discuss with you, because the survey needs to agree that anything that they send to you, it's using that point as the AutoCAD 00. Most of the civil surveys use state planes for point coordinates, and state planes have huge coordinates. We're talking about millions of feet, because the 00, it's way far away from the project. And so it's possible to work with that level of numbers. For example, I think the 00 of the California state plane, it's somewhere in the Farallon Island. It's like in the Pacific Ocean. And it's a little inconvenient to use that as a 00 for a project. And so when you talk with your civil engineer, you agree on a point that is close to the project that you can use as an insertion point, and then the civil agrees re-exporting a version of the civil file suitable for Revit consumption. Okay, so the survey point is the shared coordinate system. And then there's another point called the base point. The base point, it's also a relative point. It reports coordinates relative to the survey point in the north, south, east, west nomenclature. If it's a positive on the north side, if it's a positive value, means that it's in the north. If it's negative, in the south. On the second line, if it's positive, it's on the east. If it's negative, it's on the west. The project base will also have an elevation, and it also reports the angle of declination between the project north and the true north. And the project base point is an alternate coordinate system to report a different Cartesian elevation. A project can have two Cartesian elevations, and you see that quite often used by disciplines. For example, architects and structural engineering tend to adopt elevation datum relative to the ground level, but then civil engineers and landscape architects may prefer to use a coordinate system relative to the sea level. And so the survey point is usually associated at the sea level elevation. The project base point is usually associated with the ground elevation of the building. And so levels can be set up to report elevations relative to the survey point or relative to the project base point, depending on what the preference of the project is. So there are levels that say ground level is 0, and then in brackets you can say 700 feet above sea level. That's the purpose of a project base point. Allow for an alternate elevation datum, and it also allows for a alternate start point of the project. So think of it as the stake that the contractor places on the field as the start point of the construction. And so that's usually associated with the intersection of two grid lines, column grid lines, or at the intersection of the start of a new building, corner building. And so these 3 points, when you start a new project, they coexist. They are all in exactly the same X, Y, and Z location. Internal, survey point, and base point, they're all starting in the same spot. But then as you discuss as you coordinate the site with your consultants, the survey point needs to find a place. The base point needs to find a place, and then internal origin is not selectable. Doesn't report anything. It stay where it is. These are project settings, and so when and these 3 points are visible in the site subcategory of the visibility graphics. So you can turn them on and off as needed. And to verify that a project is using the appropriate coordinate system, you can turn the visibility of the links of these points and see if they actually match. Okay, so as a summary, origin is useful for linking projects and exporting. Survey point is the anchor point between multiple disciplines, and it's associated with a agree point in the survey. And project base point, it's an alternate datum elevation and building work point close to the grid intersections. Okay, so this is the theory. Now, how we make it happen in Revit. So this is the process, and it's a 4-step process. We have to identify, to get started, we have to identify a model that's going to become the source of the shared coordinate system, the shared coordinate. Usually the architect is the first one who gets started in the modeling process, and they're usually the BIM leads. So an architectural model is usually the model that determines the shared coordinate system. Once you identify that as the source of truth, we'll link this into the other models. So if the architectural model is the source of the shared coordinate system, that model is linked into the structure, into the structural, into the mechanical, into the landscape file. And if the consultants have already started some geometry with the project, we align, rotate, and move that source, that link file. What you don't want to do is, if you're a consultant and you're trying to align your model with the architects, you don't want to grab geometry with a big window selection and then use the move command, because a lot of the Revit geometry, it's pinned and it's anchored to spatial constraints. Think, for example, all the pin conditions of the panels, or the foundations also have pin relationships, and so there is not an easy way to select everything and just move it. In AutoCAD, you say just select everything and move it 6 inches. In Revit, you cannot do that. Once you build a model of a certain size, it becomes really, really difficult to shift your model. And even if you could do that, then the camera views of every single floor plan and detail plan is going to get displaced. And then you have to go back and fix every single view. Yeah, because your views are crop regions, windows looking at your geometry. If you move the geometry, then all your views in the project will get displaced. You don't want to do that.
Cesar, can you go into a little bit more? Let's say you have a site from a civil engineer and you want to move the building 10 feet on that site. How would you do that?
Yeah, that is a property of the project base point. Let me show you. The project base point has this clip state. That allows you to, if you move a project base point in a clip state, you're basically shifting the world. You're basically moving everything, the views, but the only thing that's staying behind is the survey point. And so that's the proper way of shifting a building. But you don't select everything and move things.
Perfect. Thank you.
And we'll do an exercise to show you how to.
All right.
So again, we identify the source of the shared coordinate system. We link that source into each consultant file. We align, rotate, and move the link to your geometry. And then we acquire coordinate systems. And to acquire coordinate system is the equivalent of aligning the location of the projects of the survey point in the 2 files. So it's like you are reading the link, the location of the link shared coordinate system, and making the survey point of your file match the one of the link. That's what shared coordinates mean. That means you are aligning those 2 points in the same spot. And the preferred method, and this is in the test, is to acquire the shared coordinates from a link, because then you are modifying your own file. You're not compromising, or you're not editing a consultant file. The alternate is publish. Publish a shared coordinates mean forcing a link model to match your location. And that is the equivalent of that is opening, it's editing the file of a consultant. And we don't do that, right? We try not to edit. It's a must know. We should not edit any consultant file. And if we publish a shared coordinate, you're actually impacting the location of the link file or the consultant file shared coordinate system. So the preferred method is to acquire. And then from then moving forward, every time your consultant sends you files, you can link them using the share coordinate method in the link options, and it's going to always come in the same spot. So 4 steps. This is in the test. So identify the source, link the source, move the source, and acquire the share coordinate. All right, let's see how this is done in practice. So let's jump into the files. So in the files that I sent you, there are these 3 files. There's an architectural, MEP, structural. These are three files. And there's a DWG file. And so what I'm going to do now is create a site model. And the site model is going to have a topo surface. And in that Revit model, I'm going to locate the shared coordinate systems to one of the corners of the building site. So you don't have to do this. I'm going to open AutoCAD and I'm going to show you what the survey file looked like. Survey files are infamous for being very complex files. And if you have opened a consultant civil file, they usually have hundreds of layers and they have a lot of information. I have cleaned up an actual survey with the layers and information that I actually need for architectural coordination. And this is a very simple site. This survey have contours represented as polylines with actual elevations. See right now, this is elevation 78. And then it goes all the way to elevation 50. So this is going down. And the interval between the contours, I believe it's every feet or every 2 feet. It's every 4 feet. So this is 78 and this is 74. It's good to understand what elevation we're talking about, because that's going to define what is the finished floor of the building. So the civil site usually the civil file or the survey file send us a CAD file with the elevations, and we need to have an idea what will be the ground elevation of the building. So this information is something that you need to work with your civil engineer. What is going to be the elevation of the ground level elevation? And for this little project, the elevation is going to be at, so this is 64 and this is 50. This is going to be at 60 feet above sea level. that is the elevation of my building here. The other thing that's important to know is a way to connect the AutoCAD file with your Revit file. And so I have made a representation of the intersection of 1 and A. This information may or may not be provided by your civil engineer. That's something you'll have to add as a link. For example, you can link your civil engineer files and make sure that you add this reference, because there you need a way to connect the civil and your architectural one. Okay, so the other thing is have an agreement what's going to be the shared coordinate system. And so I'm going to draw a line in AutoCAD from 0, 0, 0, just to understand where the 0, 0 is. This is the 0, 0 of CAD. This just happened to be very close to the site. But when you're actually in a survey file, the point references are typically associated with state planes. And sometimes the 0, 0 is 6 million feet away from the site. And so that's not a good 0, 0 to use, right? And so we need to have a conversation with my consultant and agree what point is going to be close to the site. And you can use like the center of this roundabout, or in this particular project, I'm going to choose the end of this boundary. I think this is a setback from the road and connected with the property line. And so these points seems to me a reasonable point. And again, you need to think about what the contractor might do on the field, because if the models is part of a pre-construction delivery to the contractor, they're going to use this as a way to map the start of the project. And so if this makes sense for the contractor, I will use that. So this is the location I choose to be the shared coordinate system. And again, the elevation of my building is 60 feet above sea level. And I have to clean the AutoCAD file. And cleaning the file means to verify the extent of the CAD file. So for you AutoCAD users, there's a command in AutoCAD called zoom extend. And zoom extend will display the full geometry. And if zoom extend doesn't become a tiny little dot, then that means this building is good for Revit. But if you do zoom extend and your civil survey becomes a little dot that it's miles away from the building, that's not a good file for Revit. And so we need to clean it up, remove the floating geometry that might be creating that condition. And ask a surveyor or a civil to provide you a copy of the file with this point as an insertion point, which is not an unreasonable request. It's very easy for a civil engineer using Civil 3D. It's very easy to export a CAD file using an alternate insertion point. Just before you send it to me, can you re-export it? And in the process of re-exporting it, you also get rid of all these extra pieces of information or extra layers that you might not need. The thing is that architects don't know what to ask. And so once you know that things like this is easy to ask, then it helps the coordination. Okay, that's all I wanted to see about this file. So I'm just going to close it. I didn't do anything to this. I just explained it. All right, so I'm going to create a new project from scratch, and I'm going to call it the site project. And the site project is going to be the source of information for the shared coordinate system. And inside that new project, I'm going to create a new topo surface. So I'm going to create a new model using the out-of-the-box architectural template. New model, architectural template. And then I'm going to switch to open the side view on the floor plan. And the default side view has the project origin, the survey point, and the project base point exactly in the same spot. And so for projects where you have all the control, like you know that in particular small projects, you can choose to have work like this, that the internal project, the project base point, and the survey point are all exactly in the same spot, and make sure that everybody starts with the same logic. And so it'll be easier. The problem is when consultants start at different point of time and these projects are not aligned. And once you anchor them, they are floating in different locations because they have different start points. And so when that happens, then the best strategy is to use established shared coordinates. And so I'm going to switch to a 3D view. This project has two levels. One level is called level 1 and level 2. And I'm going to rename level 1. You can just select it. And you can just type on the name of the level. And I'm going to call 0. I'm going to call it sea level. Sea level is my sea level. And then level 2, I'm going to select it. You can rename it here, or you can rename it here in the identity data. Two places to do the same thing. Level 2, I'm going to call it the ground level. And yes, I'm going to rename all the corresponding views. And then based on the information from the CAD file, the ground level, it's an absolute elevation of 60 feet above sea level. So I'm going to raise ground level to 60. So you select ground level, and the elevation reported by the ground level, I'm going to change it from 10 feet to 60 feet. Apply. Okay, so I have my sea level, I have my ground level. My shared coordinate system is going to be placed at the sea level. My project base point is going to be placed at the ground elevation. It's an alternate coordinate system. And if you look at the properties of a level, if you select a level and look at the edit type properties, the type properties of a level, the properties of the level says that it can report elevations relative to the project base point or relative to the survey point. And so I'm going to get back to this once we establish shared coordinates. But that's a type property of the levels. Okay, in addition to this, I'm going to turn on the points. I'm going to turn on the 3D points. And those are under visibility graphics. So you type VV or VG. And under the site category, if you go to the site category, The site category has 3 subcategories: the origin, the project base point, and the survey point. Those 3 points that I talked about. And you hit apply. And right now, everything is exactly in the same location. So the gizmo coordinates, those 3 arrows, that is the origin. That stay where it is. I cannot do anything about that point. That's the center of the 20-mile space. The project base point, which is the circle, right? When you select it, when you select the project base point, you must see that it says project base point in the instance properties. This is good. This needs to be associated with the ground level of the project. So I'm going to raise that 60 feet. And you can change it directly in the point parameters on the screen. Make sure you select the project base point. You don't want to select the survey point. The survey point stays in the ground. So I'm going to raise the project base point to 60. And the project base point is now sitting at the ground level. That's all I'm going to do for now. And then the survey point, which is the triangle. I don't know the location yet, but that's going to stay at the ground level. And so when I look at the properties of the level, going back to the type properties, these levels can report elevation relative to the project base point or relative to the survey point. So you see how I have now 2 alternates points of references. So I'm going to keep, I'm going to swap the elevation base to survey point. The ground level, it's at 60 foot above sea level. And then I'm going to save this file. You can just save it as a project. I'm going to put it right next to the rest of my files. Yeah, and I'm going to call this library site. And I'm going to save it. Okay, so any question here? Anybody? Is anybody behind? Is this making sense? All good? All right. So I have the site plan with 2 levels, with the survey point at ground level, at the sea level, project base point at the ground level. And now I'm going to bring the CAD file. So I'm going to go to the insert file, insert tab, and then go to the manage links. And I'm going to bring a CAD file. And under the CAD formats, you will add the survey file, which is this one, the site civil. Just FYI, you know, in Revit, you can link DWGs, MicroStation, DGN. You can link SAT files, SAT files. A SketchUp file, this was a new feature in Revit 2022. You can link Rhino files. This is a new feature in Revit 2022. And you can control the visibility of the line weights of SketchUp and Rhino files. So for those of you who use Rhino or SketchUp, you might find that a nice feature, a nice add-on in Revit. But I'm going to link a DWG. when you link something, you can decide to preserve the AutoCAD layer colors or invert them.
Excuse me, Caesar, how did you get here? Where is the manage links?
Insert tab,
Uh-huh.
manage links.
Oh, okay, thanks.
And I'm about to link the, then you go to this is Revit links, and then you switch to the CAD formats tab. CAD format tab. You can also link IFCs, point clouds, PDF. This is a new thing. This is a great thing. If you have a survey or a site that the only information you have is an as-built in PDF format, you can link the PDF and then you can scale it so that you can use it as a background. Obviously, it's going to be flat, but it's an option if you want. All right, I am on the CAD formats, and then I'm going to add a new CAD file, the civil drawing. I'm going to preserve the colors of the CAD file. Some people like to invert them because in Revit, the typical background is white. And so the yellows and the yellows don't read very well. And when you invert the colors, you use the opposite RGB. So I think there is a point in inverting colors, but I'm going to preserve it. And for now, I'm going to use origin to origin. So what that means is the gizmo of the Revit file is going to match the 000 of the file of the CAD file. The CAD file is going to place a C level. I'm going to bring all the layers. If you choose, you can also specify layers. When you specify layers, the next dialog box is the list of the layers in the CAD file. But I'm going to bring them all. Import units, auto detect is usually works pretty well. But if you link it and you see that the scale is off, then you can go back and switch it to the AutoCAD units. Civil drawings are usually decimal feet. And if your first attempt doesn't work on auto detect, then you should come back and select feet as an option. So I'm going to leave it at auto detect. I'm very uneasy about this checkbox, which is correct lines that are slightly off axis. And this is particularly true when you are dealing with legal boundaries and setbacks coming from Revit, from AutoCAD. You don't want Revit to fix, even though if it's slightly off axis, you may want to preserve it. So you don't want to be liable for Revit doing changes to the slide off lines. And then this CAD file is going to be placed at C level, origin to origin, and then I open it. So the link name, it will be listed under the CAD formats. If this is a network path, it will be listed here. And they can be done relative or absolute. It's exactly the same thing as in AutoCAD. Absolute will disclose or will force the path to be part of the path. Relative is not. And then this checkbox, which says preserve graphic overrides, will make sure that if this CAD file is replaced by another CAD file, if you apply visibility graphics to this, that those graphics overrides to the linked DWG is preserved. If you disable this and you receive a new DWG, any graphic override you done in Revit will not be preserved. You'll have to apply it again. So I always enable the preserve graphic overrides. And then I hit OK. And where is it? It must be floating somewhere. So in Revit, if you type CE, that it is where it is. It's not that far. The 00 of the CAD file is linked with the origin of Revit. So the 3 arrows, that is the origin. And the 00 of the CAD file is that. And so one thing I'm going to do is to stretch the size of the sea level and the ground level. Make sure that it's associated with the site of this, it's larger. So in this 3D view, select the ground level and grab the grips that are at the center of this work plane. And just grab one of those grips and make it larger. We want to make very big planes, or at least planes that are closer to the site. Yeah, that's more workable. And I'm going to do the same with the other one. Select this one. Now select this guy. Grab the stretch the extent of the level. What I'm doing is resizing the levels and sort of making them about the same size. Now, if I want the bottom one to be exactly the same as the one above, switch to elevations and grab the extent of the level to be closer to the other ones. This is a quick exercise in X, Y, and Z. And then I switch. This was in one direction. I can also do it in the other direction, in the front and in the back. This is the level. I grab that white circle, which is the level extent boundary, and make it sort of align with the one above below. Select the level and the white grip associate at the end of the level. Click on it and stretch it. So I did this in the 2 directions. And now I have levels that are associated with the extent of the site. Any question here? Anybody falling behind? Is this clear? So notice here, I have not enabled share coordinates yet. All I'm doing is just geometrical work. I link the file, again, repeating, insert, manage link, go to CAD formats, add, choose the origin to origin method, preserve colors, bring all the layers, place it at sea level, and then open. And then zoom extend. Zoom extend is there's a shortcut for zoom extend. You can also do it right here. Zoom to fit. Zoom to fit. That's one way to play to extend. And then stretch the levels. Stretch the extent of the level.
And Cesar, what is that, the checkbox orient to view?
This
In the
checkbox?
previous, no, in the previous, when you were inserting AutoCAD, there was an option, orient to view.
Oh, I see. Yeah, this checkbox, if you are in a drafting view, we are in a 3D view, but if you're in a drafting view, what it does, if the CAD file has a rotated world coordinate system, it will align it with the view x direction. And so this technically rotates CAD file and align it with the orientation of the view. But rarely you link anything in a drafting view. So I would use this only like if there were a detail, and you know that detail is in a strange UCS in CAD, then I would use it there. But for the most part, just leave it blank.
Okay, thanks.
All right, so our levels are in place. They are sort of encapsulating the entire extent of the 3D topo. And now I am going to create a topo surface. So I'm going to repeat this process twice. If you want to watch first, then we'll do it together. A topo surface, there are a couple of methods to create a topo surface. One is to create a topo surface by a link entity, which is what we're going to do. You can create a topo surface by bringing a point file, an X, Y, and Z point file, which is a comma separated value with X, Y, and Z coordinates. And that's something that civil engineers can extract from a survey, but it's not typical to do it that way. Or you can create it from scratch. But all the 3D topography tools are available on the Massinen site. And so everything topo is here. So these are ways to create topo surface and components hosted by topo surface. And these are ways to modify the topo surface. I don't have anything in place, and that's why they show out grayed out. Now, before I create a topo surface, I need to look at the topo surface settings. So the topo surface settings is this tiny little arrow there. It's an arrow pointing down next to the model site that disclose the graphic properties of the topo surface that you're going to create. And this includes at the very basic level, the typical interval contours and the base elevation. Where does those start from? So when I was looking at the CAD file, the intervals were every 4 feet. So I'm going to change the baseline of the intervals to 4 feet. So technically, that's all you can do. That's all you have to do. Change that to 0, change that to 4. But if you want to have graphic representation of primary contours and secondary contours, then you have to add additional graphic overrides. And so this table that you see there are graphic override for contours of certain elevation and certain increment. Like the secondary contours, which are intermediate, primary contours, secondary contours. Primary contours, they may happen, let's say, every 12 feet. And the secondary contours just happen in between. So they may have, the primary can have a darker representation and the secondary can be lighter representation or a light gray. So in this case, I'm gonna swap the subcategory to primary. And I'm gonna say Revit for the primary contours, which happen every 4 feet. display a subcategory, and this subcategory can be override in visibility graphics. So in visibility graphics, there are subcategory on the topo surface where that you can apply a different line weight. And I'm going to add another one. You can insert here. The range type, it's multiple values. Single value means that only one contour will have a subcategory. And this is useful, like if you want to display, like in red, the 100 feet, floating boundary of a site. And then one contour is applied to a subcategory. But these are secondary ones. These are multiple values. They're going to happen every feet. Yeah, let's do it every feet. There's a start and an endpoint. This is the start of this of the primary range. And I know that my project is between about 50 and 100. So I'm just going to do from 0 to 200. I'm going to do it for both of them, because nothing in the project is going to be above 200 feet above sea level. So you see what I'm doing? At the base level, we have contours at 4 feet. But in addition to that, I'm going to have a subcategory associated with the primary ones and a subcategory for the secondary ones. And I can apply different line weights if needed. A section material means when I create a section through the topo surface, what material you want to see underneath the surface. And that's earth at an elevation of -10. And then I just hit OK. Property data, this is ways to create, these are units to create property boundaries. I'm not going to do that for this project. It might be beyond what we want to learn, but this is how you can create a property boundary using angle displays. Okay, so I'm going to hit OK here. Those were my settings before I created this. Now, if you go, just to understand those visibility graphic, if you go to the Manage tab, and then you go to Object Styles, and scroll down to the topography, you're going to see that the primary contours have a line weight of 6, and that the secondary contours have a line weight of 1. If 6 is too big, maybe we change this to 4. This is really heavy. And then the secondary, you can change the color. You can say, instead of being black, then I'm going to make it dark gray. Gray, not green, dark gray. Use an RGB color. So primary contours are going to display at the line weight of 4, and they're going to be black. You can choose also to have a different line pattern. I'm just going to leave them solid for now. And then your secondary contours can be solids. You can create subcategories. You don't have to do this, but you can say, for example, 100 feet flood contour. And then that's going to be red and very thick. And then when you're creating that table of contours, you can associate a single one to that elevation. I want to delete that. We don't need that for this project. All right, so those are the graphic override for the primary, the secondary. I got here, if you click Manage Object Style, those are global settings for the topo surface.
Sorry, Cesar, I wasn't able to change the color. you know, when I click on it, it opens the dialog. I select the color, but the selection, you know, and say okay. But when I go back to the table, it still says black.
Really?
Yeah.
And you're in object styles, right? You're not in visibility graphics.
No, I'm in object styles. Yeah.
That's weird. Okay, keep it black, and then if you want, at the end of the class, I can look at your workstation.
Okay.
Maybe we can share. I can't think off the top of my mind if what may be preventing that.
Okay, no problem. Thank you.
Okay, so hit OK here, and I'm ready to create the topo surface. So you go to the massing and sites, and here's how I create a new topo surface. Select the topo surface tool, massing and site, topo surface, and these are methods of creating the topo surface. So I'm going to choose create from import. Create from import. And in this drop-down menu, click import instance. You're going to have to select the link file. Select import instance, and then I'm going to select the CAD file. And this is asking you for the layers in the CAD file that contain information about the contours. And I know this because I created the file. The files that contains the contours are the topo major and the topo minor, major and minor. So I'm gonna deselect everything. Check this none. And then I'm only going to select layer, the major layer and the minor layer. Those are contours, major, contours, minor. That's all the information that contains elevation information. This could be points. And in order to get this information, you have to open the CAD file, select a couple of layers, and find where those points or where those lines are residing. And then I hit OK here. And if you zoom forward, you see that the object styles start kicking in. The major contours are happening every 4 feet. And then the intermediate or the secondary contours, Revit does the math for you. These are not in the CAD files, but Revit creates an interpolation between the major points and between the intervals. Every point that you see on the screen is the start point and the end point of a CAD segment. And it's reading the elevation from the layer subset that I selected. Before I click OK, you may want to apply like a material. And so I don't know if there may be a grass here, or no, there's grass as an asset. No, I think I'm going to have to use the earth one. I don't have time to create a new material, but you know how to create a new material, right? So we can create a new material that's called earth, but it's called grass. So I'm going to select earth, which is listed here. And then click the green checkbox. Now I switch this to shaded. Here's my site. And it has all the contours and with the proper elevations extracted from the CAD file. Any question here? Does anybody need me to repeat this whole step of creating it? or anybody wants me to go back a couple of commands? We're good. All right, so I'm going to save this file again. And now I'm going to start establishing the shared coordinates. Let's go back to the process here. First, we identify the source of truth. We link this into the projects, move, align the link, and then we acquire the shared coordinate. All right, so before I save this file for the final end, I need to agree on the location of the shared coordinate point. So switch to the site plan in the views. Here is where you have a conversation with your engineer and say, where is it reasonable to have my shared coordinate point? I'm going to switch the geometry to on the graphic display. Let's switch this to wireframe, because wireframe will allow me to see through the CAD file. And you and the structural and you and the civil engineer agree that this is the point that needs to be the anchor point for everyone. And all I need to do is select the survey point. And to do that, you can just hover over this point and hit the tab key. I will hover over, hit the tab key until you see that I'm selecting the survey point now. That's what I want to select. I want to select the survey point. If you click and it says project base point here, you're in the wrong place. Again, you hover over, that is the project base point. That's not what I want. What I want is the survey point. So you hit the tab key, that is the survey point, and now I click select. And all I need to do is drag it out. Just move it. And I'm going to move this all the way to the point that I agree. You can use the move command if you want it to snap exactly at the right location. So I'm going to do that. I'm going to select the point and use the move command. Select the survey point and use the move command. I pick a snap point to the center of the point, and the destination or the final location is the intersection of these two lines. You see how you pre-highlight the intersection of these two lines. And once that is in place, I'm going to pin this point so that no one's moved it by mistake. So you select the project base point. Hover over or hit tab to select the point. But this one, hover over, tab. Or I can do also a window selection from the lower left to the right. And then I'm going to pin it. And when I pin the point, I'm just making sure that no one's moved by mistake. Any question here? I know this is, I'm going slow, but it's trying to explain everything. There's one more thing I need to do before I get out of this file, and this is to define the project north. And so this footprint indicates the location of the building, and the direction, the the grid line A, grid line 1 indicates the location of project north. So project north needs to be perpendicular to the view in the construction plans. And so I'm going to define it here. So to define the new project north, make sure you have on your site plan, you have a project north as the value of the orientation. And then under the Manage tab, under the Project Location panel, again, Manage tab, Project Location panel, you're going to find Rotate Project North. Rotate Project North. And to rotate Project North, you need either a CAD line or a reference plane you can associate the Project North with. So I'm going to hit Rotate Project North, and it says you want to indicate a new location of the Project North. I'm going to say align it to align. The last choice of this dialog box, and select the grid line 1. Then you hit OK. And here you go. I'm going to do it again if you fall behind. So you go to the Manage tab. First, I switched this to transparent, so you can go into the graphic display and switch it to wireframe. I'm on the site floor plan. And then you go to Manage tab and hit the position tool. It has a drop down where you can select Rotate Project North. And then you click Align Selected Line. You can also use a work plane, but you have to draw the work plane. Align Selected Line. And then you pick grid line number 1 and hit OK to this warning. And this is my project north. And so on the site level, I'm going to make 2 copies in the views. Select the site, right click and duplicate the view. And I'm actually going to call it. This is, rename it. This is Project North. And then I'm going to make a copy of this again, duplicate view. And the name of this view, when I right click and rename it, and I'm going to call this True North. And for the last one, you go to the properties of the view on the True North and change the orientation to True North. So this is the True North, which is used for site plans or site accessibility views or location illustration. And then for the rest of the project, you're going to use Project North. For the rest of the views for your construction plans, you're going to use Project North. For your site plans, you're going to use True North. And then this is the sort of truth. This has the right location of the shared coordinate points. It has the correct orientation of the civil survey. It has the True North orientation, and it has the Project North orientation. And so this becomes the source of truth for the rest of the disciplines. So I'm going to save this file for the one more time. And this is the file I will send to structural to electrical to MEP to landscape architect. And I'm going to ask them to use this file as the source of a shared coordinate system. So let's do this with any question here before I go into the consultant's file. Okay, so let's close this file. And then I'm going to establish shared coordinates with the architectural one. And so again, these are the steps. Identify the source of the shared coordinate system, checkbox, I know that. I'm going to link this file into the architectural file or the structural or the MEP. Then I'm going to align in that file, I'm going to align, rotate the link file, and then I'm going to acquire shared coordinates. Okay, so let's open the architectural file. So you go to the open, I close the library site. Now I'm going to open the library link architecture. Library link architecture. This is the consultant file. This is the architectural. It could be the interiors, or it could be another consultant. It could be the architects, etc. And notice how their origin file and their shared coordinate location, it's all in different place. When it comes to coordinate system, this file has nothing to do with the shared coordinate file. But that's what we're doing. We're trying to align them. So what I'm going to do now in the architectural file, open the site plan. The reason of using the site plan is because the site plan has a really big view range. And the view range, if you notice, it's 200 feet above ground level. And so you have this ability to see in the vertical a lot of things. I'm also going to, on the site plan, on the view range, I'm also going to make sure that the view depth, it says to unlimited, so I can see everything underneath. And on the top level, I'm going to change it to unlimited, so I can see everything above the cut plane. All right, that's the site plan. So I'm going to link the site that I just created. So this is a Revit file, so I'm going to go insert, link Revit. And we're going to search for the site plan that we just generated, the library site. Because this is the first time we're using it, I think we can do center to center. Right now, we're going to link it center to center, and then we're going to rotate it in X, align it in Y, change it in height. So center to center, it means the geometrical center of the site plan is going to get aligned with the geometrical center of the architectural model. So we're going to open here. View zoom, extend, this is where the file is at. Well, you know, I forgot to trace over the boundaries. How can I do? Yeah, I forgot to trace over the reference plane. So let's undo. Let's go back. I think I have time. Yeah. Let's undo this. Yeah, let's undo. Let's go back to. Let's close the architectural file, and let's go back and reopen the library site. So one thing I forgot is to create a reference of the grid lines. So that it's clear where grid line A and grid line 1 is for the consultants. It's very useful to create reference planes. The reference planes become part of the model, and the intersection of these two reference planes will indicate visually to the consultant where the file is positioned. And so all you need to do is, under the architectural tab, create a reference plane. Is the last icon under the architectural tab. Create a reference plane and do it 2 clicks. First click, second click is the endpoint of, or a point near the endpoint of this grid line. Escape. And then another one, reference plane. This is the A location. And escape. And that's it. The intersection of these two references indicate the location of 1 and A. So let's save this. Close it. And let's start where I was starting. So let's go back to the architectural link. And here I'm going to link the site plan. So again, you go to the Insert tab, and then you go to Link Revit, link the library site model, center to center, we said. The model is going to be somewhere. Oh, I have to look at it on the site plan. And now you see those reference planes. Those are the ones that I created. So this was the direction of A. This was the direction in Y. And so according to the instructions, we need to align, rotate the link, never move your Revit project. Okay, so I'm going to select the link. I'm going to move it where it needs to be. So I'm going to move it from, use the move command. Select the link, use the move command from the intersection of these two reference planes to the intersection of these, of A and 1. And they just happen to be, this project just happened to have the right project north orientation. So I think this file is aligned on the X and Y elevation. Let's check the Z elevation. And remember, my project is going to be an elevation of 60. So I'm going to switch to the south elevation. And notice how my building is underneath the project. And again, you always move the link. You never move your project. And so the link has the ground elevation level. And I'm going to match the link ground elevation level to the project elevation level. So you can do this using the move command, or you can use the align tool. I'm going to use the align tool. So what I'm going to do is to align the ground level of the link file with the ground level of the project. And the align method, I don't think I've taught it before, but the align method asks you to select a destination, the source, and then the destination of two entities. It's like I'm grabbing something and I'm gonna, this is the source and that's the destination. So the Align tool, you're going to find it under the Modify tab. This is the tool, Align. It's the first icon on the Modify tools. So go Modify, Align. And then you're going to align where? That's the first thing. Where are you going? You're going to the building. You're matching the building ground level. And what is that you're aligning? It's this level nested in the link file. And that's it. I want to repeat the command. You switch to the south elevation. Then you go to the Modify tab. Hit the Align button. And then where are you moving the link? I'm moving it to the ground level. And what is it that you're moving? Is level 1 of the link. And now my link, it's placed correctly in the X, Y, and Z. So I'm going to go back to the site plan. And this is it. I'm almost done. Now the last step is to acquire the shared coordinates. And I want you to look at the location of the shared coordinate point here relative to when it's going to be, relative to when it's going to get acquired. So to acquire a shared coordinate system, you select the link, and then you establish shared coordinates in the share site parameter. Establish shared coordinates, and then you're going to get this message. You want to publish or you want to acquire. If I hit publish, the current location of the survey point is going to get pushed into the link. And that's not what I want to do, because no one edits a consultant file. What I want to do is to acquire the location of the survey point. You can see it right there, and reconcile their location. So acquire it, reconcile, and now both the location of the survey points on both files are exactly in the same place. And this project also acquire the project north. You see the rotation to the true north. It's also imported from the files, from the source file. And the architectural file can now display both project north and true north. And the same process has to be repeated by mechanical, structural, MEP. And when we link all those models together, insert, they're all going to come exactly in the same location. So when I add a new file, you see in one of the options, it says share coordinates. That is the option I'm going to start using moving forward when linking the files. But I have to repeat this operation for every discipline. So it's 7:16. Next class, I'm going to start and recap the process. We're going to do the same with the structural, and then we're going to link it together to wrap the exercise. But this is how we start shared coordinate system. When something is established, when you establish shared coordinates, then you're going to see that when you hit the share site, you no longer have publish and acquire, but you can disable shared coordinates. This is the way to disable shared coordinates. That means you reset it, and then you start again from scratch. All right, so save this file. This is the architectural file. And next class, we're going to recap again with the structural model. We're going to have a test. I already told you the answers to the questions on shared coordinates. And then we're going to talk about custom parameter next class. So save this file. I'm going to close it. And then if you want to have one-on-ones right now, feel free to stay, or else I'll see you next Thursday. I'm going to stop the recording. I'll stop the YouTube. And yeah, see you guys next Thursday.
Thanks, Cesar.
Good, thanks, Cesar.
Thank you.
Thank you.